Okay, this is Qaqc Step 3. This is all about seeing all of the flights that you've done in one spot so that you can make sure that you've got all of them. Now, LiGeoReference is where we left off last time. It can only show you one flight at a time. So we need to put it in a different app where we can see them all at once. We also need to subsample the point cloud so that the other app, Cloud Compare, so that Cloud Compare doesn't crash, we need to subsample it. And we also need to merge files together so that they're easier to work with, so that you're not juggling bajillions of files, because we have 100 flights in total, and hopefully we can graph 100 flights at the same time as long as they're subsampled enough. But so that dealing with 100 flights isn't a nightmare, you need to also merge them together. And so that's what I'm going to show you how to do. So this is where we left off last time. And this is the folder that we had last time. You'll remember the base is where we put all of the Rhinex files for this particular flight. And we also have georeference result, which is now full of this stuff. So sometimes you get a nice LAS file, sometimes you don't. This LAS file is a raw, rough file that you can open in Cloud Compare, but it needs to be subsampled. So let's do that. If you get this file, you can follow. If you get this particular kind of file here, then you can follow this process. So the app that we're going to use to subsample is an app I made. It's really runs in the command line. It's not something I did, but all I did is I made this nice graphical user interface so that you don't have to put stuff in the command line. It's much easier this way. So it's asking us to select the LAS files that we want to subsample. So we go back into our georeference result folder. And we want to subsample this file here. And this is going to keep every 500th point. So it's getting rid of 499 points and out of every 500. So let's do that. So here it's telling us it's subsampling the file. It's giving us the name of the file that it's subsampling. And this is much quicker than doing it. As you see, it's already done. This is much quicker than doing it in Cloud Compare. And the next step is asking us to merge. We have nothing to merge because there's just one file that we just did. So for now, we're just not going to merge anything. Let's go look at what we got. So here, this app adds subsamp to the beginning of the name. So you can see the name is the same, it just has subsamp in front of it, and the file size is much smaller. And something like this is much easier to repair, to open. So I just double click on it, apply all, make sure this says input, and say yes to all. And then we can look at our flight. Now it does, when you zoom in like this, it does look fairly sparse. But what you can do is you can increase the size of the points so that they look bigger. So we're going to go into, I clicked here, and we're going to go look for cloud, and then within cloud, point size, and we're going to click, I don't know, 5. So here you can see the area that your flight took up, and then you can add another one beside it to see how that ended up looking, to see your coverage. Now, you also have all of these files here. These are in the proprietary LiData format, and you have one file per line. So sometimes when you don't get this file, and you get all of these files that are more processed, if you merged all of these together, it would be larger than this one because this one's raw. This has a lot more data in it. It's more precise. It's georeferenced, but it's also, because it's more data, it takes longer to process. So if you don't get this thing, then we can get these to show up in Cloud Compare, and I'll show you how to do that. So first you go into LiGeoReference. Then you click Convert to LAS here. This will take the that proprietary data and convert it into LAS. So we click export. Here it's processing. It's converting it to LAS. Each one of these flight lines is being converted to LAS. You can also look in this folder here. You can see the name is the same, but the extension is different. It's .las instead of ydata. Now, one thing to note is that this is running on the computer. I think that it actually does run quicker on the computer. Transferring to the computer and back onto an external drive, in my experience, it would take like 20 minutes to transfer, I don't know, maybe 5 square kilometers of LiDAR data at its full depth. So that's pretty fast, all things considered. Considering how large of an area you'd be transferring. So you can try transferring it on the external drive, and then transferring it to the computer, working with it on the computer, and then transferring it to the external drive afterwards. See what works quicker. So it's done making these LAS files. Here you can see all of them. So we're going to do the same process as we did before, which is to subsample each one of these LAS files, and then at the end we're going to merge them together. And this process is the same, like the merging process is the same if you're merging flights together, because all it's doing is, it doesn't matter if it's a flight line that you're merging together, or if it's groups of flights that you're merging together, the process is the same. It's just merging these different LAS files together. And so you would follow the same steps if you're merging different flight areas together. One thing to keep in mind is each time you subsample a flight, like say we subsampled this flight, it would go from being, one every 500 points, and then you'd be subsampling it again, one at each 500 points. So at some point, if you be careful re-subsampling stuff, you might subsample it to the extent that it disappears. So you want to watch out what you're subsampling and what you're merging. So let's go to our little app here again. We're going to click browse to select the files that we want to subsample. We're going to highlight these ones because these are the ones we want to subsample. These are the ones we created earlier, or this is the one that was created raw. This is the one that we subsampled earlier. Open. We're going to keep it at the old setting. Actually, we're going to subsample it down to every thousandth point. And now it's going to go through each file, and it's going to subsample each file individually. Again, this is much faster than doing it in Cloud Compare. Okay. Now it's asking us to merge. If you only want to merge and you don't want to subsample, there was a button to just skip that whole step. So the process is the same for merging stuff. So we want to merge the subsampled stuff together into one file, just so that it's easier to deal with. So you don't have to open, all of these different files. So I selected all the files that I want to merge together. Open. Click OK. And now, because we're merging the naming structure, you want to tell it a name of how you want to merge stuff together. So I'm just going to call it merge. And save it, okay. And that's it. That's how quickly it merged them together. So let's go look at, there's our merged.las. Let's, I misspelt it, but whatever. Let's go open it up. And there we go. So you'll see the result is the same, basically. One of them, this one comes from the raw file that we opened, and this raw file is just one file, and then if you don't get that, you can then follow the other process to get this result. So these are two different ways, depending on what LigeoReference gives you, that you can take the results, subsample them, merge them together, and then after they're subsampled and merged, you can then look at them in Cloud Compare. Yep, that's all I wanted to show you. See you.